It'd be wise to view the video on difference of sample means featured in the Unit 7 videos prior to viewing this one. One of the biggest things to grasp is the unknown parameter we are going to be evaluating in a two-sample t-test or two-sample t-interval. It is not two means. The parameter itself is merely the difference. Consider these two situations. Both feature a parameter of 10. In the first case, the difference between the means of 460 and 450 is 10. In the second case, the difference between 40 and a mean of 30 is also 10. Therefore, in both instances, the parameter is 10. It is purely the difference in means that concerns us. In most every test we run, the null will assume that the two means are equal. This implies that the parameter mu1 minus mu2 equals 0. If the parameter is the difference, then the statistic is also the difference, but it is the difference between two sample means. Following the test statistic formula on the AP-STAT formula sheet, we will recognize that t will equal the difference in sample means minus the difference in population means divided by the standard error of the difference of sample means. We will need to substitute the appropriate values into the formula and report the test statistic. There's a new condition to confirm in step 2 of the write-up. The probability theory behind the sampling distribution of the difference of means requires that both samples be independent of one another. In other words, we are not allowed to risk randomly selecting any of the same individuals or units in both samples. Also, the normality condition is met when the sum of the two samples is at least 15, provided no outliers or strong skewness are present. Dot plots or stem plots are still important to establish normality for both populations involved unless the populations are said to be normal or the sum of the sample sizes is at least 30. A sum of sample sizes of at least 30 excuses us from creating or checking any graphs to establish normality. We will typically rely on the calculator to calculate the proper degrees of freedom and to provide a p-value to use in deciding whether to reject the null.